Okay, so yesterday you guys were asked about what was the hardest part of what we've been learning so far in this unit, and today I want to ask you what's the easiest part.
Can we open a window?
Yeah.
I'm done.
And
I'm just gonna go density.
good.
Like having to be just put next to that, don't they have like a super strong smell, so they have to smell all the chemicals and stuff.
Okay, who still needs a stamp? All right, sorry, we do have to rush a little bit today because we have shorter class period. But I did want to show you guys the acid real quick because there was a change in the beaker with the hydrochloric acid again. So the pencil with the green metal that was holding the eraser on, that one did not erode, but I did throw in another one with like a, sorry, I'm going to borrow this, with a silver metal piece on the back, which I guess would be tin maybe. It's gone. It took a day for that to just disappear, just get dissolved in the acid. The paper clips, they look fine. They look unaffected, so it may be because they're galvanized or...
What's the green one? Like you said this is tin. What's the
It may be made out of the same stuff, but it's
Diluted?
it's painted. It may be protected because it's painted a different color.
Make your armor of like green pencils.
Is it like doing that to the paint or that one pencil, or is it like that?
What's that?
Like, was it cracked before, like the pencils?
Yeah, yeah. It's the paint on the pencils is slowly getting.
Plus the wood is expanding, so like stuff on it won't dissolve.
It has a protective coating on it, so that's my guess.
Run up with a sword and like slash your armor open.
The razors came off.
All right. So, dun 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 dun. All right. So today I'm going to go over your review from yesterday, Emily. Raise your hand, please, if you managed to get through the review. I know you guys had. Ms. Richardson said, "Oh, excellent. All right." So yeah, I'm going to go over some of those answers. I'm not going to go over all of them, but I want to get a feeling for how you guys feel about it. And then we might do a bit of a review at the end there. So go ahead, please open up to page number 36. Okay, so on page 36, already lost my pencil. There it is. On page 36, we have various containers that are holding solid, liquid, and a gas. So, could I get a volunteer to describe for me what they think the solid should look like? Yes, Michael.
All tightly packed together and at the bottom.
Yes, all tightly packed together and probably down to the bottom. Just like we've seen with this demonstration, when we have a solid, they're all just quietly sitting at the bottom, tightly packed together. Unless what?
Unless it got frozen to the top.
Sure, unless it adhered to the top because it was frozen or there was some kind of adhesive. Yes.
Well, when I'm throwing stuff at the bottom, I got kind of confused because the solid didn't necessarily take up. Like drawing an ice cube in the container would be more realistic, but a lot of people drew circles at the bottom of the container, just at the very bottom,
Yes.
given the shape of its container. So I kind of drew circles along the side of the container.
Well, that was very observant to, honestly, what I expect from you guys for this question is just to have tightly packed particles together in neat rows, because that's generally how we represent solid matter. But you had a very good point, because solids do not take the shape of their container necessarily, unless it was water that had been frozen into that shape.
Also, who says that it's the container? Who says you're not just drawing the particles of the object?
Yeah.
Sure. Yeah. All right. How about liquid? Who'd like to describe a liquid? Yes.
They're free flowing, kind of less tightly packed.
Yeah. So they are not as tightly packed together. They have a little more energy, and they are able to flow over one another. So that's why you can get that kind of movement with a liquid, because the atoms are able to flow past each other. They don't have the same bonds that you have with a solid. How about the last one, a gas? Yes?
They're kind of frenzied and they're all over the place.
They're highly energized. They're maybe the easiest way I think I'm going to be describing it all day is they are highly energized acrobats that like to jump around and do flips and go everywhere. Yes. So they are shooting in all directions. They've got lots of energy. On this page, on page 36, I'm not really going to talk about these descriptions down below because we just did describe them. Yes?
Are we not going to have plasma in the test? It's all over the test.
When we're talking about states of matter, we're not going to talk about plasma. We're just going to talk about solid, liquid, and a gas. It's important that you know about plasma, but it's not necessarily going to be on the test in this kind of an example. Yeah.
What about page 31?
I will get there. Oh, sorry, page 31. Oh, the CO2 carbon cycle. We're not going to worry about this. This is the carbon cycle. It's not, you're not going to be tested on it. It was just an extra thing that we added. So don't worry about, because I know you guys are trying to get caught up, but don't worry about that page. So real quick, before we move on, first let me ask, does anyone have any questions on page 36? Next, I would like to see out of 5 being good, 1 being bad, how do you feel about page 36, about the particle movement, particle formation? How do you feel? All right, excellent. Makes me feel good. All right, flip over to page number 37. 37. Change. So on page 37, up at the top there, this hopefully looks kind of familiar. Number 1, well, here we have the 3 stages of, or excuse me, the 3 states of matter. We have a liquid, solid, and a gas. And yeah, anyways, let's start with number 1. Transitioning from a solid to a liquid. What do we call that? What do we call the transition from a solid to a liquid, which is number 1? Yes?
Melting?
Melting, yes. Going from a solid to a liquid is melting, correct. Number 2, going from a liquid to a solid. Yes? Freezing. is correct. Freezing. Number 3, going from a liquid to a gas. Going from a liquid to a gas. Yes, Charles. Yes, that's correct. Evaporation or vaporization. And number 4, what do we call it when we go from a gas to a liquid? Yes, what do you think? Condensation. Condensation is correct. And the last 2, let's start with first going from a solid to a gas. What do we call that? Going from a solid to a gas. Yes, Gavin. Sublimation is correct. Yes, it's called sublimation. What's that?
It's just sublimation.
Well, but we're going to cover all the bases. So, sublimation. Then what would be an example of sublimation? Yeah, Natalie.
Like solid to gas.
Going from a solid to a gas, which is called sublimation. Can you think of an example of that?
When dry ice melts, it goes from dry ice to CO2.
Yes. So when we did the dry ice lab, when we put the dry ice in the water, because the water was so warm, we were able to very visibly see that the solid ice transitioned directly into a gas. We saw that sublimation. Now, what do we call it when it goes the other way? When it goes from a gas and turns into a solid? What do you think? Deposition, yes. When a gas turns into a solid, it is called deposition. Can anyone think of an example of that? What do you think?
Dry ice freezing?
Dry ice freezing? Well, it actually goes, it goes from a liquid into a solid. Any other examples, Emily?
Like if the air is so cold with the gas outside, and you into the solid.
Yes, so another way of saying that is when it's foggy outside, when we have a lot of fog outside, and we have a sudden cold snap, which happens here in the valley occasionally. Well, we always have fog in the winter, but if we have a really cold night, really cold morning, that fog will actually turn directly into ice and start falling out of the air. Yeah, or frost on the grass.
When we breathe out into that like mist, isn't that like the particles freezing?
That is the vapor condensating. Turning into when it's a cool morning out and you breathe out and you can make the cloud of mist, that's because your warm body, the warm vapor from your lungs, which is you're breathing out a lot of water, basically warm water vapor. When it encounters cooler air, it starts to condensate. So then it forms a little mini cloud. Yeah.
I was looking on page 37 because I wasn't here yesterday, and it says there seems to be smoke coming out the iodine block. Did you fill this up?
I will get to 37 in a second. All right, so let's see, sublimation, deposition. So, does anybody have any questions? Oh, sorry, Gavin. Which part of the page were you asking about? E. There seems to be smoke coming off the iodine block. So you are trying to say whether the events below are examples of melting, freezing.
I know what's happening, but I just didn't know. Could you show me a video of that happening?
Maybe another day. Remind me tomorrow. We'll probably have time at the end of the test. That's a good.
If it's smoke coming off a block,
Yeah, an iodine block.
solid,
Yeah, I know. I've never seen iodine. He knows which one it is.
So I probably have not. Personally, I've never seen smoke coming off an iodine block. So I'd like to look that up myself. But
Honestly, I thought that would be like a dry ice testing. But since
we'll look. I'll see if I can find a video for tomorrow after the test. Yeah.
Would hail be deposition, or would it go through liquid first?
It goes through stages.
Being pushed up and then
Hail, yeah. So hail starts as water vapor, which evaporates, from the Earth's surface. It makes its way. As it makes its way higher and higher in elevation, it encounters cooler and cooler temperatures, and basically the warm water vapor starts to condense a little more. It goes through condensation until there's enough condensation, there's enough weight, essentially, that it falls back to Earth as rain. But hail is rain that has encountered very cold temperatures at high altitudes. So it did actually go from a liquid to a solid. Yes?
would deposition happen if you like shot water into space? Casually shot water into space.
If,
Let's fun that.
let's see, if you shot water into space, you would, if you had a device like a spray bottle that could turn basically water into water vapor or very, very fine particles, then yeah, it would go through deposition because it would go from that vapor into a.
But then it'd hail.
Oh, it was cold because of the temperature.
I can just imagine sneezing at it without your helmet off. I know it'd be impossible.
Yeah. I mean, that would be my guess. It would just, if you had something to turn it into a vapor. Okay. So, does anyone, please raise your hand if you have any more questions about any of these questions on page 37 from yesterday or today. All right, so let me see a show of hands, how you guys are feeling about these changes of state. 5 being good, you feeling pretty comfortable? 1 not so much. That's good. That's excellent. That's good to see. All right, let's go over. Let's flip over to page 38 then. Yes?
Kind of bounding off that question, what would happen if you put gas in space? Would it just immediately dissipate?
That's what we just did. That's what we just did.
If, yes. Well, it's a slightly different. It's a slightly different question. If we released gas into space, I suppose depending on its proximity to an object, if we released gas in the vacuum of space, it would probably stay together because gas still has volume and volume has mass, right? So gas is still matter, so it takes up space. And if it takes up space, it has volume, which means it has mass.
It would be impossible to dissipate. Like, wouldn't it just separate in all directions because space would be vacuum or whatever?
It might, but because it has mass, it means it would have some kind of it will have a very slight gravitational pull on itself. That's a really good question, though. If you have enough gas in space, then it'll pull other gases to it, kind of like Jupiter. And if you keep gathering more and more gas, then it turns into a sun.
More and more gas thrown back.
Yeah. Well, it just does it on its own. All right, let's look at number 1. Can I get a volunteer? What do you think number 1 is, Michael? Why do you think number 1 is a compound? Yes, so number 1 is in fact a compound. Number 1 is B. It does have 2 different types of compounds. What's that? Oh, yes, yeah, new material, not a new atom. So we have, number 1 has 2 different types of elements that are attached together. Off the top of my head, I would say that looks kind of like water because the black one would be like your oxygen atom, and then it has 2 hydrogens attached to it because that's how H2O is made. Number 1 is a compound. What about number 2? Can I get volunteer for number 2? What do you think?
Mixture of elements.
Mixture of elements. Number C. Yeah, that is correct. Number 2 is C. There's a mixture of elements. So we know that, first of all, that these black dots and white dots are elements because we represent atoms by themselves like this. When you have an atom represented by itself, basically it means it's an element. You can also actually have an atom, you can have two atoms that are represented in color that also would be considered an element. It's a special molecule called a diatome. So we know that we have two different elements because we have two different types of atoms that are represented on here. Two different colors. Yes? Oh, you want to volunteer? Okay, what is number 3, Michael?
It is a mixture of elements and compounds.
Yes, so number 3 is going to be a mixture of elements and compounds, E. So we know that there are compounds in this example because we have molecules here which have two different types of elements attached to each other. We also know that there are elements here because we have these two atoms of the same type that are attached together. And even though there's two of them, they're not considered a compound because they are the same type of element. So or the same type of atom, which means they're an element. What about number 4? Yeah, what do you think?
Mixture of compounds.
Mixture of compounds. That's correct. D. So we have a mixture of compounds. We have those H2O molecules and that other compound that was in number 3. So we know those are compounds because each one of those molecules is made up of two different types of atoms that are bonded together. How about number 5? What do you think, Owen? A, yes, that's correct. 5 is an element because these black dots, they represent, because they're by themselves, we know they represent just a single atom. And since they're all the same type of atom, we know that they're an element. How about number 6? Yeah, Natalie. B, compounds? Yes, that's correct. B is correct. It's a compound.
That line is that.
Gosh. Yeah, I guess that does say that. I did not notice that earlier. I might change that for next year. All right, number 7. Number 7. What do you think? A, an element. That is correct. Number 7 is an element. We know that because we have each one of these molecules has two atoms of the same type. If they were different types, it would be a compound. But because they're the same type, we know they're an element. Yeah?
Is carbon dioxide like C4O2 or something like that?
Carbon dioxide?
Yeah.
Yeah. CO2. So carbon dioxide is CO2. Because, well, we'll learn about how you name molecules a little later.
I'm trying to think of one that could be the molecule.
Oh. All right, number 8. How about number 8?